Hi guys, welcome to my YouTube channel. My name is Precious. Alright, so in this video we are going to be looking at the concept of sine rule, so which usually goes together with that of cosine rule, which will bring to us in subsequent videos. Right, so here, what is sine rule all about? The both of them are tools that we make use of in solving triangles. Okay, so and we also use them in solving concepts of trigonometry and bearing and distances. So of course, both of them give relationship between the sides and the angles of a triangle. So if we have a triangle as given here, ABC, so the angles are represented with the capital letters, while the sides facing each angle is represented with small letter of the angle. Okay, so here will be small letter A, B, and C, respectively. All right, so now what is the statement of the sine rule? It is actually a relationship that states that the side of a given triangle is directly proportional to the sine of the facing or the opposite angle. So it's stated in this way that A all over the sine of A is actually equal to B all over the sine of B, and is also equal to C all over the sine of C. Okay, so by implication, all of the ratio of this is actually equal throughout all the sides of the triangle. And of course, you know, we can make use of the three in solving problems. So depending on which one you are given and the ones you are asked to look for, we might use these two, or these two, or this and this at the same time. All right, so and of course we are going to do examples to see how to make use of this sine rule. Now, but before we begin to talk about how to use sine rule, it will be good that we start looking at how was this formula developed, or how was it derived. Okay, so I'm going to do some constructions here that will help us do this derivation. Let's bring a perpendicular bisector here. Okay, so let's draw a line here. Let's call this place D. And then let's also bisect here. Or even before bisecting this one, let's use this one to make a case. Now, from what we have here, you can clearly see that if I call this place H, that's this distance H. Now, let me still leave here as my C, and let me call this place. Now, that's the distance from B to D. Let me call it X. Okay, so you can see that by SOHCAHTOA, you remember this relationship, SOHCAHTOA, that is the definition of our, what do you call it, trigonometric ratios. Okay, so from here we are told that the sine of an angle is equal to opposite all over hypotenuse. So that means if I write the sine of B, for example, that's this particular B, with respect to triangle ABD. So if I talk about angle B, the sine of angle B, that will be equal to the opposite, which is H, and that is all over the hypotenuse. In this case is C. Remember that this is with respect to triangle ABD. Okay, so and from here we can clearly see that our H is going to be equal to C times the sine of B. Remember that this C is a small letter C. That's the side C. Okay, now I can call this equation 1, and if I do so, I can also try to look for the sine of C, in this case, using triangle ACD. So if I use triangle, let me use this now, triangle ACD. Okay, clearly you are going to now see that our sine of C will be equal to the opposite now is still H, and that will be all over the hypotenuse. In this case is the facing side, which is B. so all over B. Okay, so remember to close here. So from here, you can see that our H in this case, if you remember what I did here was a cross multiplication, that's here. All right, so if you cross multiply here also, we will get that our H is equal to B sine capital C. Okay, so if we call this equation 2, so you will clearly see that from equation 2 and equation 1, okay, so from equation 1 and 2, you will see that since H is equal to H, so it means that C sine of B will be equal to B sine of C. And that's very beautiful. Okay, so what can we do now? So from here, you can clearly see that if I divide both sides by, for instance, if I divide both sides by sine B here, and divide here by sine B, what am I going to get? This will cancel this. All right, so we are now going to have C, and if I divide through again by sine of C, I am now going to have, of course, sine of C will join this one here. So this will now cancel this. So you can see that what we now have is C all over sine of C is equal to small b all over sine of capital B. So we have gotten this part of this particular rule. And of course, we are now going to do something to our relationship, or sorry, our triangle, to be able to get that of sine A. So let's keep this somewhere. Now, what am I going to do? I'm now going to clean this place. So let me clean that construction I did there. And now let me construct it somewhere here. Okay, let me have this way. Okay, in that case, I can remove this. Okay, so you can see I didn't even use this X, so let me remove it. Okay, and let me now remove this D here, and let that D come here. Let me use E instead, since I've used D before. Okay, so in this case, I will now have my A here. Remember, A is the side facing capital A. Now, see what is going to happen here now. All right, so from here, if we now consider triangle ABE, watch what I'm saying. That's, I'm considering this first triangle up here. So you will see from there that the sine of angle A is going to be equal to the opposite. Remember, we can see call here our H. So the opposite, which is H, all over the hypotenuse there. Remember that this is a perpendicular bisector, so this is angle 90. Sorry, I didn't remember to say that when we did here. Okay, so here is now going to be C, being our hypotenuse. Okay, so that now means that our H, once again, is now C sine A. And we can call this equation 1 still under this construction. And then the next construction, what can we have there? We can see from there that is in triangle. So from triangle CBE, that's the triangle below. So talking about angle C, you can see that the sine of angle C there is equal to the opposite, which is still the hypotenuse, which is still your H here, all over the hypotenuse now, which is A. And so from there, let's now go up a bit. So from there, we are now going to have that our H in that case is now equal to A to the sine of A. All right. Call this equation 2 now in this case. Or maybe we can call this 3 and 4, whatever. So if we now compare equation 2 and 3 now, or 1 and 2 again, for this construction, you will see the same thing will happen. So you are going to see that in equation 1, you can see that the sine of C sine A rather is now equal to A sine Okay, so in this case, it is, sorry, sinC, not sinA. Sorry about that mistake. Okay, so it will be A sinC. Okay, so here, see what I'm going to do. I'm going to divide through by sinA sinC at the same time. What is going to happen is that A will cancel A here, sinC will cancel sinC here, and so that is quickly going to give me C all over the sine of C is equal to A all over the sine of A. And clearly, assuming that this is my equation star star, and the one up here is equation star. So if you join the two, you can see sine A, C over sine C is equal to B over sine B, and the same C over sine C is equal to A over sine A. That therefore means that all of them are actually equal. So A over sine A is equal to B all over sine of B, and that is equal to C all over the sine of C. And that's how we generated the sine rule as stated up here. Now remember that you can write the sine of A on top and then the small letter a down. So all right, so moving forward to examples, here we have example 1 asking us to solve the triangle below. Okay, so to solve this triangle here, what it means is that we should find the missing sides and angles. All right, so here we can see side A, which is represented as X, is missing, angle A and angle C. So what are we going to do? So you can carefully see that, of course, we cannot start anything. Remember our sine rule, A all over the sine of A is equal to B all over the sine of B, equal to C all over sine of C. Now, of course, there is nothing given in A. The angle A is not given, side A is not given, so we can't make use of this one. So we'll rule out that part. Okay, so in other words, we are going to make use of the other two sides, which is your B over sine B equal to C over sine C. Of course, we can see our B is given, that's the side facing angle B, and it is given as 10 all over the sine of angle B itself, which is given as 66, and then is equal to side C is given as 4 all over the sine of angle C. Okay, so we are going to be looking for the value of angle C in this case. All right, so from here we can clearly see that if we cross multiply here, this is going to be 10 sine C to be equal to 4 sine 66. Okay, so of course, we can clearly now see that our sine C alone is equal to 4 sine 66 all over 10. And what is sine 66? Of course, we can press two of them together. So 4 sine 66 is giving us 3.65 approximately to 2 decimal places all over 10. And that is our sine C. Okay, so from here, it means that sine C alone is now equal to, if you divide this, you get 0.365. Okay, so how do we then get our C? Of course, angle C is now going to be your sine will come over to this side, and when it does, it becomes the inverse. So we are looking for the inverse of 0.365. And then if you check that, 21 degrees approximately. 21 degrees approximately. All right, and that is a value of C. Remember, we are asked to find the missing side, so an angle. So A and C are missing, and then small letter A. We found capital letter C. So how do we get capital letter A? So can have that angle A plus angle B plus angle C is equal to 180. and you know the reason, sum of the angles in a triangle. So here we are looking for A, and our B is 66, our C is 21, everything is 180. So A alone will be equal to 180 minus, of course, if you sum these two, you are going to get 87. And so our A is simply equal to 93 degrees if you do this subtraction. So we have gotten our A, and we have as well gotten our C. So we can now use sine rule. Maybe I call this my I and call this II. So let's take that the third one now is III. So here we are looking for side X, which is our small letter A. So we can now use small letter A all over sine A as equal to any of this. We can maintain our small letter C over capital sine C. And that is going to give us, of course, here we are looking for A, which is now our X, and that is all over the sine of 93. That is equal to, and so this is going to be equal to X sine 21, we are cross multiplying, is equal to 4 sine 93. And then, of course, my X alone will be 4 sine 93 all over. Of course, I can divide here by sine 21. Okay, so by the time I now simplify what I have, that will give me the value of X. Let's quickly do that. Okay, 4 sine 93 is giving us 3.99 to 2 decimal places. Now all over sine 21 is giving me 0.36 approximately. And then if you divide this, you are going to have 3.99 all over 0.36. That's giving us 11.08, which we can call 11 cm approximately if we want. Okay, so here now we have gotten the value of X, we have gotten the value of angle C and angle A, and that has given us all the sides and all the angles of the triangle that is given. So we have solved the triangle completely. All right, so now there is an exercise here, which is example 2, which I would like you to do. Here we are given that we are asked to find angle Q and side P in a triangle. What you're expected to do is to sketch this. If you sketch it, let's say here is P, Q, and here is R. So we are given angle P as 129 and angle R as 26. Okay, Q is not given. So here we are giving side R as 10. And then we are asked to find side P and angle Q. So these two is what we are asked to find. So I'll leave that as an exercise for you. Kindly do that and show me what your solution is in the comment section. All right, so this is where we end it for this video. Please kindly subscribe to our YouTube channel and do give a thumbs up to our video. In case you have any question, you can also reach us and we will also answer you. All right, we'll see you in our next video. Bye.